we're going to talk about how we execute these functions. Okay, and this part might get a little confusing because it's probably something you guys have never seen before, but it's good to know because this will help us manage complexity. Basically, when things get a little more complex, having this very structured way of understanding how evaluation works with functions is very good. So the first thing we're going to do is here we have a function square x. Here, notice I defined it a little differently. Doesn't really matter. When I define this function square, what I'm going to do is I'm going to create the function with the appropriate signature. So this is my function signature right there. And then I'm going to set the body of the function to everything indented after the first line. Oh, one thing I didn't mention is that every time you define a function, you want to indent the next line. Okay, usually just press tab, or there is some standard out there way to do 4 spaces or something. Honestly, it doesn't really matter. And then once you do that, you set the body of we set the body of the function to everything indented after the first line, and after that we bind the name of the function to that function in the current frame. What does that mean? We have our name. What's that function name? Square. Remember, this is function name, and this is the formal parameters, and this together makes the signature, and then we bind the name of the function to the function. So basically what you can think about is objects. These are things in memory. These are the actual functions. And basically what we have is we bind names to these functions so we can use the names to reference these objects in memory. Okay? So objects are a little more complicated than that, but we'll talk about objects later in the course. So don't worry about that too much. Just for now, think of them as things in memory of the computer. And now once we have the user-defined function, we now need to call it, because a function that we don't call is quite useless. So every time we call a function, we actually create a new frame and we form a new environment. Okay, I'll talk about what this means a little more later. But then once we have this new frame, so here we have a new frame, we bind the formal parameters to the arguments. So our x. So remember, this is called a formal parameter, and what we pass in is called an argument. This is an important, subtle but important distinction, and we always bind the formal parameters to the arguments that we pass in. So x is bound to 5, and then what we do after this is we execute the body of the function, and what's the body? We return the square of it, so we return 25. Okay, so let's look at an example of how this actually works. So let's take a look at this. Hold on, let me edit something real quick, just for instructional purposes. Let's visualize this execution. Okay, so the first thing we're going to do is we're going to import the multiplication function. Again, this is built in, can take in many arguments, so that's why it's the ... And then we define squares. So what do we do? Well, let's look at our rules. So we create a function with the appropriate signature, set the body of the function to everything indented after the first line, and then we bind the name of the function to the function in the current frame. So a lot of stuff happens, but it's really simple. We just make square and we attach it to the function in memory. So we basically created space in memory with the signature, and then we bind the name, which is square, to that. And it happens that the name of this is always going to match this with def statements. Okay. Later we'll see some exceptions to that rule, but don't worry about that for now. So now, notice that we did not execute the third line. Why is that? Because you only execute the body of a function after you call the function. So now we have a call expression, so we're going to call the function. So what do we do when we call a function? We create a new local frame, forming a new environment. Then we bind the formal parameters of that function to the arguments passed in. Okay, so first thing we're going to do, create a new frame, then bind x to 5, right? Formal parameters with the arguments. So that's exactly what happens. We have a new frame, we call it square. And now we have a new environment, and our environment is basically composed of this frame and the global frame. So this is a local frame and a global frame, okay? And again, I'll talk about environments later, and it's also going to be, this is a pretty simple example of an environment. It's going to make more sense when we do a little more complex examples, and you'll see exactly what an environment is. So then we're going to return the multiplication of x with x, and that's 25, so the return value of this is 25. And then what you notice is at the end, the frame collapses, because what the computer does is after it's done, it just discards all the frames it doesn't need. We only need the global frame, right? So that's what happens. Now, here it's kind of hard to notice exactly what happened, but if we have an extra variable that's in our global frame, right, and we bind it to that, what we're going to do is we are going to basically do this entire process again, but then at the end we're going to have a new variable in the global frame bound to 25. So that's how environments work with functions. So let's talk a little bit more about environments in general, because I know they are a little confusing, but what have we seen so far? The only two things we've seen so far is the global frame only. We saw that with this complicated example. It was all in the global frame. Then, what else have we seen? We've seen a local frame followed by a global frame, and that's the square function example. Okay? So here's a local frame, and here's a global frame. So, environments at the end of the day are sequences of frames. So here, an environment is this local frame first, and then the global frame. And then every single name evaluates to the value bound to the name in the earliest frame of the current environment. What does that mean? What does that mean? If I want to look up x within my function or something, I will first check my local frame. So that's the earliest frame, right? That's the newest frame in the current environment. And then if x is there, in this case it is, I just get 5. Otherwise, if it's not here, then I go to my next frame in the environment, which is global frame. So it's kind of like a step-by-step process. And this will be more clear when we look at a little more examples. But I kind of just want to introduce these rules to you, have some time for you guys to think about it, and then I'll clarify with some more examples. Okay? So, and the steps for looking at names and environment, so this only pertains right now when we have only this simplified structure of only a local frame and a global frame. We first look in the local frame, and if it's not there, then we look in the global frame. Pretty simple. Later, when we define what parent frames are and stuff, this will get a little more complex, but honestly, it's not too bad. And after you just do a lot of examples, you will find that environments are actually quite intuitive, and they definitely help with figuring out exactly how the program executes. Okay, and so I'm pretty much done now, but before I end, a couple of things I want to talk about. A lot of times, the best way to learn this material is to just play around with some crazy stuff. So here, I made this example on my own, just because I thought I tried to confuse you as much as you can, but I encourage you to go on Python Tutor. I'll have the link of that on the description of this video. But basically, go to this link and play around with just a lot of combinations of some crazy stuff you can think of. Maybe do some simple stuff too, just to make sure you have like a sanity check that you know exactly how it works. And if you have any crazy examples and you have a question about it, please feel free to ask your question in the comment section. I'll be happy to answer them. And also, one more thing I want to talk about. One thing you can do is also, if you want some extra practice with programming in general, now that we've described exactly how user-defined functions work, one thing you can do is you can go on the 61A website. And again, my material is mostly based on this course. This course is a little more intense, but basically what you have is you have these practice questions. Okay, so this one's pretty easy. It just wants you to find a plus the absolute value of ab. Okay, so and then you can define functions, and then we want to return that. So this is an example of a question you might have. So now these questions, though, at first they might seem easy, but they progressively get harder. Then we have largest factor problem, something like this, and then we have this we haven't talked about conditionals yet, so don't worry about this. But yeah, actually, you should be able to solve the first few parts of this, but next time we're going to talk about conditional statements, and then you'll definitely be able to answer these questions. But conditional statements are quite intuitive. But yeah, I do want to say that the problems on this website, they will be quite challenging because I mean it is a college level course. But using these ideas, you do have the ability to figure out. It'll take some time, but it'll be very instructive. I highly encourage that for those of you who are interested. All right, thanks for your time. That's all I have.